whenever you have a problem like this, say y is a function, let's say, of two variables, x1 and x2. You can talk about the total differential of y. And the total differential of y is just dy. dy by itself, there's nothing in the denominator. And this is the total differential of y. Dy dx is the rate of change of y with respect to x. So if dy dx is 2, that means y increases by 2 units for a 1 unit increase in x. And now, dy by itself, you just interpret that as the change in y. But it's not the change in y with respect to the change in x. It's just the change in y, the total change in y. So it's like you think of dy dx. Well, let me give you the definition of dy dx. Suppose you just have y as a function of x. Then what is dy dx? It's defined to be the limit of this difference quotient as delta x goes to 0. But see, dy dx is like delta y over delta x. But now dy by itself is just the change in y. But it's not with respect to x1 or x2. It's just the total change in y. Okay. And yes, it's important to understand this intuitively. Now the formula, you should just memorize this formula for this case right here. It's partial f partial x1 dx1 plus partial f partial x2 dx2. Now, dy is called the total differential because it's the dependent variable, the total change in the dependent variable. dx1 is just the differential of x1. It's just the change in x1. dx2 is just the change in x2. Okay. So in words, what this says is the total change in y is this partial derivative, which is just the change in y per unit change in x1 times the change in x1, plus the change in y per unit change in x2 times the change in x2. Let me give you a simple case to illustrate this. Suppose we have this function right here, y equals 100 plus 2x1 plus 4x2. This is our function. Notice y is a function of x1 and x2. Now, using the formula for the total differential, we get, again, this. Now, in this case, what is partial f partial x1, David? What is partial f partial x1? 2. Yeah, just take the partial derivative of this function with respect to 2. And what this means, since this is a simple linear function, it means y increases by 2 units for every 1 unit increase in x1. So dx1, we'll just keep it as it is, because that could be, positive or negative. What is partial f partial x2? 4. If you just take the partial derivative of this with respect to x2, it's equal to 4. So our formula here for the total differential of y is dy equals 2 dx1 plus 4 dx2. In other words, the total change in y is 2 times the change in x1 plus 4 times the change in x2.